Welcome to the second homework of the machine learning. Let me open the files and there is example data in here and example images, and this is the public test Python file, and this is the test utilities, and this is the logic files. In this homework we are doing logistic regression. In this exercise you will implement the logistic regression and apply it to different data sets. These are the outlines, and first of all we are running the cells and importing the packages numpy and hw2. This is also using numpy and matplotlib. We will check it later on. Let me come here and run this one. And I was using base Python, I guess. And the second logistic regression in this part of the exercise, we will build a logistic regression model to predict whether a student gets admitted into a university. And the first one of the problem statements, suppose that you are administrator of a university department and you want to determine each applicant's chance of admission based on their results on two exams. We have historical data from previous applicants. You can use a train set for logistic regression, and for each training example you have the application scores and two exams and admission decision. You test to build a classification model that estimates an applicant probability of admission based on scores from those two exams. We will start routing the dataset. For this task, the load data set function just below into variables xtrain and utrain. And xtrain contains exams onto for a student, and utrain is the admission decision, and utrain 1 if the student has admitted, utrain 0 if the student was not admitted. Utrain this is loading the test. Let's print xtrain. And let's take a look at those examples: X train, U train. Let's print the U train and what's gonna happen. And let's take a look at the example 2. I think this is rounding, okay? Yes, as you can see in here, rounding. Sorry, right here. And let's delete this. I don't need this anymore. Weird variables, 5 element x is here, and check the dimension of your variables. Another useful way to get familiar with your data dimensions. Let's print the shape of the x train and u train. It's given the shape for us. There are examples, and this is the visualization before starting to implement any learning algorithm. It's always good to visualize the data if possible, because data to the pilots were X and are two exam scores, and the positive and negative examples are shown with different markers, and we use a helper function in the hw2 Python generator. Let me check the helper function and utils. Helper, no. Okay, it's given the pilot. I just want to try to make use a helper function. I am just trying to find a helper function from the utils, but I couldn't find it. And let me find pilot data. Yes, pilot data in here. It is here pilot data, and this is the definition. We have x u equal 1 and negative label probably u equals 0. So positive equal to u, and that's equal to 1. And negative equal to u when u becomes 0, and we are just in displaying it right here. And gold is a bullet logistic regression model. To fit this data with this model, you can then predict if a new will be admin based on their scores on the two exams. There is some sigmoid function which is given in here. Recall that logistic regression, the model is represented as where function g is sigmoid function. The sigmoid function is defined as, let's implement a sigma function first so it can be used by the rest of the assignment. This is exercise 1. Complete the sigma function to calculate, and there is a note for it. Z is not always a single number, but it can be also array of numbers if the input and you like to apply the sigma function each value in the input array. So if you guys stuck, you can check the ints. Okay. Yeah, when you are finished, try testing f values by calling a sigma with x in the cell below the larger positive values of x. The sigma should be closer to 1, while the larger negative values of sigma should be closer to 0, noting that sigma 0 should be given the 0 0.5. It's given error because I haven't run it. Let's click from hint. Okay. Expect output is sigma 0, 0 0.5, we have to write g, it's returning g, and 1 divided 1 plus numpy dot x explanation z, and I think this is enough. Okay, let's run it. Right now I am checking my error. I already defined it, but unexpected indeed. Okay, okay. And run it. It gives a 0.5, and it's expected. And running this one 30 also so cost function for the logistic regression in the section you will implement cost function for logistic regression. And this is the it gives our examples. There is a gradient for logistic regression. Okay, let's continue. In the example 2, implement the cost function for logistic regression. This is the exercise to complete the cost function using this equation below. And recall that for logistic regression, the cost function is of the form which is here. M is the number of training examples in the dataset, and this is the called single data point, which is given formula in here. So model's prediction value over, which is actually labeled, and G is a sigmoid function. It might have for calculate and intermediate variable. Note that as you are doing this, remember the variable x train and u train are not scalar values by the matrices of shape of Mn and M1 respectively, where n is the number of features and M is the number of training exams. And sigmoid function that you can implement below this part. And let me click it. Some details for me. I'll just continue to reading the other stuffs. And after this example, we're gonna go to gradient for logistic regression. Let me solve the whole problems in this exercise too. And let's start. first of all, I have to define the z with numpy dot. Okay, let's define it. Z and np dot uh, x and w plus b. After that, I have to define a predictions, which is contained to the sigmoid function. Okay, predictions sigmoid z, and after that, I have to compute cost function for logistic regression. Okay, I have to define a cost which is equal to some equations. These equations already connected with the predictions and numpy dot. Okay, uh, and after that, what should I do? I have to define a total cost because we are returning total cost. Okay, and we will just connect the cost and the total cost. Okay, let's write our cost function, 1 divided by m, and after that star and mp dot y and mp dot log predictions. What's happening? Log pre, pre predictions, and after that plus mp dot 1 minus y and comma mp dot log 1 minus predictions. And what should I do right now? I have to connect the cost and total cost. Okay, cost and total cost, returning the total cost. What's happening? What's the problem? I don't see any kind of problem, but it says there's a problem. Prediction signal. I have already defined that. I don't see any problem. Sorry, that it says a problem. I don't see any problem. This is strange. Anyway, and we have to calculate this one, and which is comes like this. We have to calculate the cost. So starting with z, which I already defined in here, this is the dot function. So x and v and plus b and z till here for here, and it gives us this one. We are using the dot function, and it is actually gives an here. We gives an name as spread addiction, and it's a sigma function set. So to calculate the cost to do this, we are just using this function, and which is, where is it? It gives a sigma function which is the one, and we are calculating the total cost. Let's check again this problem. What's the problem? Let's ask the ChatGPT. Empty. It says empty things. I don't see any kind of problem. Let's just skip this one. Gradient for logistic regressions. So I don't want to make it too long. I will not read this one. In here, and let's take a look at the hints. And we are using extent w plus b, which is in here. So let's just implementing the function mathematical functions in here, and here the gradient distance similar to previous assignment. You will not find the optimal parameters of a logistic regression by model by using gradient descent. You don't need to implement any for this part. You simply run the cells, okay? A good way to verify gradient descent is to be working correctly. And let me run this one too. There are many details and there are some expansions of it. And GMV this one for the iterations. And we are calculating the cost for each of them. We are putting a decent boundary for this one as admitted. It gives an error, but I don't see any kind of error in here. When I asked ChatGPT, it didn't give a solution. To evaluate an logistic regression, we can evaluate the quality of parameters we have defined by seeing how well the learned model predict in our training set. You will implement a predict function below to complete the predict function to produce and learn pattern vector WMP. First, you need to complement a model function x power and I. gb dot x power I. For every example, these are the functions. So we have to calculate the z, and let's write. And defining the predictions. And after that, what should I do? I have to define a p and equals the predictions is greater than 0.5. P is predictions greater than the 0.5, greater and equal than the 0.5. And if you run this, it comes true because simple function is Still same as we done it before. Actually, probably I wrote this. It gives an W error again. Let me check it. I already defined it, but it gives an error in here. This is best, but this is not best. In this part of the exercise, you will implement a regularized logistic regression to predict the weather because peak from a fabrication plant quality as sense Q during each microfig. Various tests you ensure to use it function correctly and problem state manage. Suppose you are product manager of the factory, you have to test results for the some microfigs onto different tests. From these two tests, you would like to reject it or accept it, from which you can build a logistic regression model. Let's run this one. Loading the training set and displaying and the check dimension of the variables. Let's run it. And this is our variables, which is hundreds and let me run this one. We are seeing is like some rejectors and acceptors. It is not looking logical, so we have to make some feature mapping on it in this matrix, and to display it run this one and this one, we have to make to mapping, for we cannot understand there is nothing like this one, so we cannot take it as a good data set for us. There are another good outliners. All of them look like the one way to feed the data, where is create to more function from each data point to provide a function feature. We will map the features into polynomial terms like kind of methods. And we are calculating the cost function in here, or another exercise is computing the cost function. This is the lambda divided by 2m summation with j over power 2. And if we come here for the regression computation, we are taking the square and Let's write it. Uh, what will gonna happen? We will use the sum function and square function. First of all, I have to use the reg cost is equal to mp dot summation sum, and which is inside of the mp dot square. It calculates w, and that's it. I just implement this method and it passed. And if you come here, regression computation, we are first taking the square root, which is the part of this. For the total, we are having the regression cost is multiplying this one, and we have lambda in this part cost with the regression, which is in here. We are turning into the total cost, just a regression in here. I already defined it, but it gives an error. I'm just checking my codes and I don't see any problem. Thank you.